What's up, my dudes? Back at it again with another video. I'm happy to say we're actually going to be trying out some TIG welding in this video. I actually was able to pick up some of the stuff I need from a local store, specifically tungsten and a certain kind of tungsten that I wanted to use. Heard a lot of good things about it. It's durable, it holds, you know, it can last, it's got a good arc start. So I wanted to get this certain kind of tungsten and no one had it, but I actually found it. So I'm gonna get my welder set up. We're gonna start trying to get into some TIG welding because we've got to get this motor apart, get all the boost and stuff together, and then get the intercooler piping made up. And I need to know TIG before that. So a couple of things that I got the other day. I got some ER 4043 aluminum filler rods in 3/32 and 1/8. I got both because I may need both, and I want to try different rod sizes and just see how the puddle acts, because the thicker the rod, the more metal you put into it, the more cooler you will make the weld. So technically, you know, if you have too big of a rod and you're trying to weld at too low of an amperage or whatever, you could have an issue with the weld not even happening. So I got those. And then as far as tungsten for the TIG, I don't know a lot about TIG, but as everything that I've read and watched videos on really said that 2% lanthanated tungsten was almost the best. I did want to get the 2% thoriated because I heard it's not very good on AC, and I'm going to be doing a lot of TIG and I need a lot of AC style welding. So I did get 2% lanthanated. I got the 1/16, the 1/8, or 1/16, 3/32, and 1/8. So I have all those. Smaller tungsten, you have a more defined arc and a thinner weld, and then bigger tungsten, bigger arc, bigger weld, wider weld, etc. I also picked up some brushes to clean the material with, so it's very clean. I picked up a welding manual because you can never not know enough. You know, you can never stop learning. It's not, I want to learn as much as I can, and I've watched a lot of videos, but I picked this book up just so I can do some extra reading and be more informed, I guess. I picked up a set of gloves. Now these aren't welding gloves, I don't believe, but they offer more dexterity so that I can be more precise with the welds. And I think they'll be okay. Now I know the material will be hot, so I gotta watch my hands, but I got that. And I was looking for a tungsten sharpener because you should have a dedicated wheel or whatever for your tungsten, so you don't put different types of metal into the tungsten, because that can cause your arc to be very wonky. So I grabbed a mini tool grinder from Harbor Freight. It'll be dedicated for the tungsten only. I will not use that on anything else. So we're good there. I'm gonna get my torch set up. I need to get the tungsten sharpened. I need to get it in. I'm probably gonna use 3/32 tungsten today. I have some sheets of aluminum over there. I believe they're all 1/8 inch, but I think there's a 1/4 inch over there as well. I'm gonna get some pieces cut and try and do some T-joints or fillet welds. I don't know the exact terminology for it, but I'm gonna get some pieces cut up before my propane runs out, because it looks like it's about to go right now, and that sucks because it's Saturday and it's cold and I want to do some work. So I'm shivering, by the way. I'm gonna get some pieces cut up. I'm gonna try and get the torch set up. I'm trying to go through the torch setup so that you guys know what to do and stuff like that. My kit, surprisingly, my kit came with a 5, 6, and 7 cup. That refers to the size. I'm assuming it's not millimeters. I don't know exactly what it is, but it's the size of the nozzle here. And it also came with 1/16, 3/32, and 1/8 collets. Collet is what holds the tungsten still inside the body. Also comes with a long cap and a short cap. Short cap if you need to get any tight spaces. I haven't read the book for this welder, but everything I've seen, I should know how to start it and set it up and stuff. So I'm gonna get some pieces cut, and then we'll catch back up to get the wand together and start ticking. Well, I'll try to anyways. All right, guys, so I got some plates cut up. There were 2 of these size. This is a 3-inch piece by, I think, 8. And I cut 2 pieces, and then I just cut this one in half. I'm gonna practice with a lap joint like this, and then I'm also gonna try and get a T-joint, or I don't know exactly what this is called, but I'm gonna try and get this edge, tack it in place and weld it, and then I'll weld the back side too. But I wanna see, when I weld it like this, what the penetration will look like on the back side. And then as far as this one, getting that to weld nice and neat. I have to clean them up with the wire brushes yet, and I also have to get my wand or my torch together, and we can start getting into some welding. Oh, I also cut up this 30 by 30 plate so that I can connect the negative lead to the plate, and the plate will then transfer you know, power through the material, so I wouldn't have to just clamp directly to the material, because that could get in the way of the weld, and I don't want that. So I cut this plate. Hopefully it doesn't heat up and melt the table. Hopefully this doesn't melt the table. I need to get actual table, but this is gonna work for now. So yeah, I cut this up so I can have my ground on that. Hopefully I don't get shocked, because I actually don't know how this works, but I assume that it works this way, so we'll find out. Yeah, so I'm gonna clean up these two pieces of material with the brush, this joint, and then we can start getting our wand together and get this thing turned on and start welding. So like I said before, I did get a 3/32, which is this, and 1/8 inch ER 4043. So I'm just gonna take a piece out of this. It's a 1 pound. It doesn't say the length, but you can see the length. It's pretty long. So I'm gonna cut it down into 3 pieces, and I should be good with that. All right, and these are about the size as they are. This is the 3/32, almost the same size. So this should be good enough. I can feed in, dab, and should be good there. Now I'm just gonna get the torch together. All right, for this, I'm gonna use the 3/32 tungsten, which is this here, 2% lanthanated, 3/32. The limit for amperage on this, what I've been researching, the 3/32, the limit is 250 amps. That's the max on the machine. I mean, the max is 200 on the machine, so I really won't need to go any higher than that. This will be able to do everything I need. But I also got 1/16 for like the really small stuff. I'm gonna practice and see if I can even weld some razor blades, but that's wishful thinking. I mean, I'll probably be able to do it eventually, but we're gonna get into it and we're gonna see what I can do. I'm gonna start off with the 3/32, and we should be able to go. So I'm gonna get my the mini grinder that I got specifically for the tungsten. I'm gonna open that up, get a tip ground on the tungsten, and then we can put together our torch. All right, I got this my little, you know, tiny little joint hooked up. Look how smooth this is though. Like, there's no, like literally no vibration. And this is pretty awesome. So I'm gonna use this to grind a tip on our tungsten real quick. Pull out a piece of this, slides. 2% lanthanated tungsten is blue tipped. Come on out. Okay. For a tip, you kind of want somewhere between like 45 degrees and 45. Is it 45 or 65? I'm not sure, but it's got to come to a point. And when you grind tungsten, you want it to go lengthways, because the way the arc is, if you were to like just like somehow grind it sideways, the arc will be, it'll be everywhere. It won't go straight to where you want to weld. So what you gotta do is you gotta grind it in the direction so that the arc will come out that way. So real quick, we're gonna get a little bit of grinding going and get this tungsten ready. Now that tip, I know it's hard to see. It's not straight though. It looks like it goes like this. So I'm gonna try and get this straight real quick. Alright, that's good. Really fine point. We'll see how this works, and if I need a more lengthened tip, I'll do that. But for right now, it's good. And then I can move my little grinder back. All right, these are called lenses right here. This is the collet body, and these are the collets. When you tighten, you tighten this into the wand, and then you slide one of the collets that fits the tungsten size, so which is 3/32, which is this one. And then when you tighten on the cap, that's what will tighten the tungsten in the torch, and it won't move. Once you loosen the cap, the tungsten can be able to fall in and out. But whenever you tighten it, it puts pressure on the back of this, and these slits that are in front of here close up then on the tungsten and hold it still. So basically that's it. I'm gonna go with the widest lens because I want the most coverage, because this is my first time doing welding with this. So I definitely would like to have decent coverage so it doesn't look like shit. So. Just making sure it goes through. Make sure I got the right one. This is brass, I believe, or copper. The threads will strip, so you can't, you don't want to crank it down or anything. Just get it snug, and it will move. Slide our collet down inside, and then our tungsten slides down inside that. And then our wand or cap, however you want to call it. If you're in a tight spot, you can use the smaller cap and cut the tungsten down. That way you have more room to weld around smaller spaces. But I don't need that, so I'm just going to use the big one. And then as far as the cup, it tightens onto the collet body. And then when you're ready, push the tungsten down and out a little bit, however much you prefer. I don't actually know how much, so I am just gonna pretend I know what I'm talking about with that, and stick it out a certain amount. I will have to look into that to know exactly what, but just gonna tighten this down. Once you have it tight, like snug, this won't move. So I feel like that's pretty good. I'm actually gonna push it in a little bit. Now, if anybody knows TIG welding, you can tell me if that's wrong or not enough or what, but I'm gonna go with that. Again, you don't have to crank this stuff down. It's very fragile stuff, but you do wanna make sure it's kind of snug, and I'm gonna go with that, and we're gonna see how that works. Actually, I'm gonna put that on pause. I'm gonna go get propane. I'm fucking freezing. And as much as I don't wanna buy a $25 20-pound tank, I'd rather get a refill. Ace isn't open on the weekend. How convenient. So I'm gonna go get propane. I'll be right back, and I'll see you guys in a little bit. All right, we back. It's actually the next day. Last night I couldn't find any propane for a good price. So today I went to Walmart and grabbed a thing for like $40-some. So I was happy with that. I wasn't gonna pay fucking $65, $70 for a thing of propane. Fuck no. So I can just take my other one and go get it filled at Ace tomorrow. But all right. We got our tungsten sharpened, we got our plates cut, we got our material set up. I'm gonna turn on the machine. Everything's ready to go. I need to get my helmet on, get my gloves on, and then we can give it a go. I'm not sure exactly how high to set the amperage for this, but we're gonna see. So, real quick, I'm gonna go over some things. Pre-flow I have set at like 1 second. Post-flow I have between 6 and 8 seconds. I'm not gonna use pulse right now. If I was doing some type of material where I needed to not warp, I would want pulse because it delivers the penetration but also allows it to cool, which will keep it from warping. Right now I'm not gonna use the pulse. I'm gonna just try and freehand it with current and frequency. Because I'm not using pulse, I don't have to worry about the ratio amps or the pulse time balance. So hertz frequency, I'm gonna have it at like 120 hertz. Transformer styles were capped at 60, like that's all they could do. It was 60 or nothing. Like, so this is an inverter machine, which allows me to change the frequency at which the amperage comes through. So my frequency is about 120 amps or 120 hertz, which should give me a pretty accurate weld. What I understand from what I've been reading and all the videos I've been watching, the higher the frequency, the tighter the arc, the tighter the weld, the thinner the weld. So I'm gonna have the frequency between 110 and 120 hertz, and we'll see how that goes. As far as amperage, I'm gonna look it up real quick, but this is 1/8 inch, I believe. So I'm gonna look it up and see, you know, what the range is. My 332nd tungsten gets 250 amps. I won't need that for this. I'm assuming it's gonna be like 100 amps, and I'll probably be at like 80 with the foot pedal, because I am gonna use the foot pedal first, and then later down the road I'll try the switch on the thing. But right now I'm just gonna try the pedal. I'm gonna look it up real quick and I'll be right back. All right, so I couldn't find like a specific chart or anything for amperage per thickness of material, so I'm gonna wing it. I'm gonna get this machine on real quick. All right, pulse off. 2T, so we have the pedal, AC, and high frequency Tig start. I'm gonna leave it at 100 amps. I'm gonna see if it works and how well it works, I guess. So we got our material here. I'm gonna have a lap joint, or like a lathe joint right here, or whatever you call that, lap joint. And then I'm gonna try and get a piece that's stood up like that and see how that goes. So first I'm gonna try this lap joint, and we'll see how it goes. I also have to set my CFH, which I'm probably gonna have around 15. So I feel like that's probably a good set. I do have air blowing out of the machine, so I may have to set it higher, but I'm gonna set that at 15. All right, so what I'm gonna do first, I'm gonna tack it. And one of my buddies told me just try and like kind of weld it without any filler. So that's what I'm gonna try and do first. I'm just gonna tack it in place and then see if I can get a nice bead down across the plate. See how it goes. Well, I don't think I have enough amperage because I was all the way down on the pedal, but try it again and I'll try to put more heat into the parent material, which is the plate. So I think I may need more amperage, maybe because the material is a little colder. So I'm just gonna bump up to 120 amps. We'll see how that goes. And I'm just gonna try and get a nice little melted puddle as we go down. So we'll see what happens. Oh man, this shit is so fucking dope. I don't know if I want to touch the material yet. I don't know if it's that hot, but yeah, it's pretty warm. Yeah, it's pretty warm. Turn off the machine real quick and we'll get a little look at it. So, only thing I can say is it looks better than I thought it was going to look, to be honest. Now, what I think is that because everything is so cold here, my shop is very cold, maybe I should have preheated the material. Maybe that would have helped. But this section was really hard to melt. I had to really sit on it for a while before it started to go, and it was very slow. I would move forward and I would see the puddle not to follow, and I would have to come back. From about here on, it was melting pretty good, and you can see it was slow. I sped up a little bit, and then I found a rhythm, and it started to go. And by the time I got to here, because I guess from the leftover heat from the tack, it moved really well. And you can see the divot. I accidentally, well, I forgot, but I let off of the pedal too abruptly. I should have let off pretty slowly, like downslope the amperage, like nice and slow. But all I can say is, goddamn, boy, that's actually, yo. It looks way better than I actually thought it would, and that's not even with any filler. That's just with the material melting to itself. I wouldn't weld something like that in the field, I don't think, but it looks good. It looks really good, and all I can say is I'm excited. Okay, so now that we have that, I'm hyped as shit, bro. This is dope. This is dope. I'm excited. It's not as hard as I thought it was gonna be. I actually didn't really think it was gonna be that hard from all the videos I've been watching. It looked pretty easy, to be honest, but it looks great. It's looking really good. So I'm gonna let that cool down so I can handle it, and then we can examine it a little bit further, or I can examine it because I want to see it. I want to look at it. It's definitely warm, so we'll catch back up in a sec. All right, guys, look at this a little closer now that it's cool. The welds look nice. I mean, the fusion, because there's no, I guess no fillers, no weld, but the fusion looks good. It's extremely cold. The material's extremely cold. It's extremely cold in here. So all I can say is that there wasn't a huge amount of penetration through the back side, but because of this being on this and this being cold, this was acting as a heat sink, which pulls some of the heat out of the material. So I would assume that this is only being held on by the melted material to the top of the plate. So it's probably not a great weld. It looks nice, and I assume it would probably hold something, but it's probably not what you would consider structural. What I've been reading is like when you TIG without material, like without adding any aluminum in, it's good for like food places and stuff. I don't know exactly, but it seems like that would do there, but it looks really good. I'm gonna clean up this side, and I'm gonna try and weld this back side as well, because I need space to do my T-joint. So I'm gonna clean this up real quick, scrub it down with my brush, and then we can try to take this side too. All right, this time I'm gonna try and add some aluminum. I'm gonna try and dab and see how it comes out. You know, hopefully it looks nice. We'll see though. But yeah, I am gonna try and dab and see what happens. Hopefully I'll dip my tungsten right. Looks good. I mean, other than the end, because it started to get real nice and warm. I should have backed off the amperage a little bit. Still, you know, getting the hang of it, but it looks good, dude. I'm excited. This is nice. I gotta get better at feeding the filler though, because this dab and just getting closer to it, it's kind of annoying. But hey, that looks good. That looks good. Obviously the material is really cold at the beginning. It's hard to get a start. Once I got it started, it was going really well. And then at the end, it's got a lot of heat in it. Started to make a bigger puddle, and I let off too quickly. And then I went back over it because there was a tiny hole. Other than that, it went along pretty nicely. Now, whenever I get into like welding two pieces butted together, I probably would have burned through there and made a bigger hole. So I gotta practice. I will practice that. I'm gonna get this T-joint set up, get it tacked in place, and then we can see if we can weld this T-joint on here. It's about getting this thing tacked. Alright, I'm assuming I can't tack it without a T-joint without some filler. I know this isn't magnetic. That's cool. I'm just going to try and use it as like a piece to hold it up so I can tack this. So, see if this works any better. Honestly, don't know where I'm at with the amperage because I'm not looking at the machine, so I'm just going off the feel. So see if we can get a decent weld. I'll probably have to stop and switch out my filler, but see what we can do. Well, that looks ugly. gonna grind my tungsten to make it a little sharper so it stops wandering. Real quick examination of that. It looks like poo. I'm not sure why, but you can see from the back, there's a lot of heat being transferred into the material because the back was melting. I guess this is just something I'll have to keep, you know, practicing on and try and get more of the arc into the base material than that, because this is more of a heat sink than that, because this is touching this metal. Probably what it is. So I'm gonna resharpen my tungsten, and then we're gonna try again, and I'm gonna try and get more of the arc into the base material so that it doesn't burn through the T-piece. So I'm gonna grind that quick, let that piece cool down, and then we can get back to it. All right, let's try again. Let's see what we can do. Hopefully this time goes better. Okay, all right. I think I'm getting the hang of this. So if you can see right here, it looks a lot better. It acted a lot better. Yeah, it looked a lot better. It acted a lot better. Other than the beginning of getting it started again right here. The only thing I really got to work on is controlling the amperage, keeping it still, and also feeding the wire into the puddle at the correct time. But it looks good. I mean, I'm not upset with this. I was upset with that, but this looks a lot better. So it's warm, so I'm just gonna flip it around and do the backside and see if, now that it's warm, I can get a better weld along the backside. I really gotta get the hang of feeding wire, bro. That's my only thing. I feel like that's the only thing fucking me up right now. I mean, it looks all right, I guess. I'm assuming this is what happens when you weld without pulse on aluminum, and you're new like me. I did make a hole the first time, and so this whole bottom row here was like almost completely melted through. I did fill it, and then I went back over this weld, so that looks better, but this isn't as good as I wanted it to be honest. It is my first time welding with TIG though, and I must say, it's not as bad as I thought it was gonna be, to be honest. So, I mean, the only thing I can do is practice more, right? So that's what I'm gonna do. I need to get some steel filler rod, and then I can start doing some steel stuff too, like exhaust work and stuff like that, like manifolds maybe. I'm gonna try and just get most of the aluminum stuff learned super quick, so I can get this, you know, kind of kicked ass and shit. My only issue at the moment is whenever I start the arc, the arc wants to wander a little bit, but then it centers. And then getting the hang of all the controls and stuff. I will be trying the 4T with the button, because that takes me out of the equation, and if I'm fucking up the foot pedal with the amperage or whatever, you know, that can kind of solve a lot of things maybe that I'm running into right now with too much heat or too little heat, or, you know, I can just focus on moving down the lane and also working with pulse. That's good for aluminum because it gets the penetration, it gets the heat that it needs to be, but it also allows it to cool so you don't burn through and stuff like that. So a lot of things I'm gonna have to experiment with, but this is awesome. I'm excited, I really am. All right, my dudes, for the sake of the video, I sacrificed the intake of the CRX because it was just a few chopped pieces because I didn't have a welder. And I'm gonna try and weld these together. If you can see right there, there is a big gap. So we'll see what happens, but I cleaned up the metal and I'm gonna just try and get a decent bead on it and see what happens. I guess we'll see how it goes. I'm also using 1/8 filler wire instead of the 3/32. I think this will help keep the temps down, and it may just help overall. So let's see what happens. Well, it's tacked. It's like it starts to work and then it just... That's probably why pulse is invented. Alright, I'm gonna turn some pulse on and see if we can make something happen. Let's see how this looks. Suck at this. So experimenting will teach you things. First thing, always make sure your fit up is 100%. Obviously this wasn't, I knew that. I was gonna see if I could try and fill gaps. No. It looks like shit. And I was just trying, you know, just trying to like see what I could do to try and fill a gap. And it looks like shit. It looks like even worse inside. So it'd probably be better if I had a piece that had better fit up, but I just wanted to see what would happen, and now I know what happens. So I'm gonna see about maybe possibly getting another few pieces cut. Yeah, I don't have any, I have lots of steel, aluminized steel and shit. If I had the filler rods, I could do it, like start with some of this stuff, but I don't. And yeah, so I need to get some steel filler rods, but I really didn't want to mess with any of that until I got the aluminum stuff down, which aluminum is more difficult, what I'm hearing. Obviously I'm seeing it's pretty difficult. So yeah, aluminum is hard, but we're gonna get it figured out. I'm gonna get a few pieces cut up and see what we can do. Okay, so I got this plate cut up, I cleaned it, used the wire brush on it. I'm still gonna use pulse, which is like 1 pulse per second. There's a low, which is 0 to 25. 25 would be over here, and then there's a high, which is 25 to 150. I'm only gonna do like 1 pulse per second. Ratio, pulse amps is 30% of the max ratio is what it'll fall to when it's not on the pulse. And then balance time, I can't remember. Pulse time on is half of, I can't remember exactly which one this is, but I'm actually going to use the button. So I hooked up the button and plugged it in. It's actually ran with the torch handle, and I unplugged the foot pedal. So I'm going to try the torch handle style button and see how this goes. Hopefully I weld something decent, right? I wanted to try the foot pedal because I feel like I need to get used to it for certain things, but I guess we'll see. We'll see how it goes. Oops, got my tungsten stuck because I was looking at the freaking... Let's try that again. I guess it's not enough pulse. I'm gonna go to like 20. See what happens there. Fuck it, I'm turning pulse off. Alright, I had turned pulse off and I took the switch off because I don't know, it just wasn't working for me. This is just foot pedal doing my thing. I'm gonna try and make some more decent welds. I mean, it's not bad, it's just gotta get used to the foot pedal and stuff. It's going all right. Keep going. That looks a lot better. Still gotta be used to doing this freaking feed don't, man. It's really weird. Alright, so none of these look great, so it's whatever. I got a lot of practice ahead of me, which is okay. But the best one, honestly, is probably this one, which looks good, looks even, looks flat, good feed. I did go back over a couple of these just to see, like, maybe I need to add more material or something, and then I went over this with just 120 hertz to see what the hertz change would do. Best weld honestly was with a no filler, so boo-hoo, great, it's crazy, man. A lot of these welds kind of look pretty ass water, bro. They're not that great, but it's a learning curve, you know. I didn't think I'd be great at it right away. I thought I'd be okay, which I wouldn't even say I'm okay, but I can do it. It's just not beautiful. Definitely have a lot of work ahead of me, which is totally fine. I'm willing to learn. I'm gonna put in the time, so I'm cool with that, you know what I'm saying? But it definitely looks nice. I definitely need to I bought that welding book. I'm gonna start reading that and try and figure out what more I can do to help the welds, help me figure out how to weld. The torch is heavy. I didn't expect it to be that heavy, to be honest, but I guess because of like everything weighing down on it, it's just hard to kind of maneuver some shit. Yeah, I know, it's just got to get used to it. Got to practice more and just keep trying. So that was you guys seeing my first time welding with a TIG, which is it's not great, but it's not, I've seen worse with TIG. So, you know, we'll get there. But I'll see y'all in the next video, guys. Deuces. Psych! Okay, I decided that I wanted to try and TIG some steel, so I went and grabbed some stainless steel rods. And I have some of this old aluminized steel piping that we used for Ty's car. I don't know how this is gonna react, so I'm gonna take my time, turn it to DC, see what happens. I cleaned up the material. I really just want to see how it welds before we end this video. So I know we said it was over, but it's not. So we're gonna set the camera real quick. I'm gonna get it. I'm gonna get the machine on, and we're gonna see what it looks like. All right. I'm gonna see if I can get a decent tack on here. I removed my 4T switch so I can have better control of the electrode, the torch. So I'm hoping that this helps, not having the switch up there as well. So I'm just gonna try and get a tack and see what happens. Try and get a tack on this and see what happens. I think I need to grind my tungsten. Alright, let's see if that works. I'm a little confused, but that's tacked. Alright, I cleaned my tungsten. Hoping that that's it, because I'm kind of confused, but we'll see. I think my batteries are dying on my helmet. Keep flashing myself. Alright, I think I got this figured out. I'm gonna try and get a little bead going. See what it looks like. I'm not really good at this, but we'll see how it goes. Doesn't look bad. I'm gonna try putting the clamp on the part and see if that does anything better. So I'm getting a really wide arc for some reason. I'm thinking it's too much amps. Bump it down to around 55. See if that makes a difference. I wonder what I'm doing wrong. I mean, it could be just be the material, because this is aluminized steel. And this is stainless. So much different than aluminum. Alright, looking at this piece, it doesn't look great. I mean, obviously. Maybe I don't have it. Maybe I'm using too thin of a filler wire. I'll grab a bigger piece. But the welds look very thin. They don't look great on the inside. If anyone can give me tips, let me know. This is aluminized steel though, I believe, which is why I think it's welding like shit. But I'm gonna do some more welding, and I'm gonna tack this bitch on here. And because this is, you know, thicker metal, it could take more heat. I'm gonna use a thicker wire and see if we can get this to look pretty maybe. Okay, this is it's using 1/16. So I'm gonna tack this in place. See if we can get a decent bead on it. We'll see how it goes though. Of course there's a gap on one side, but whatever. Try and get it going around this side. I did turn the amperage up to 80, but I'm going to turn it back down to 70 something. I gotta keep turning it. It looks good though. Like it's coming out pretty well. Here comes the hard part with the gap. I don't know if I'm gonna do this or be able to, but we'll see. Accidentally got some weld on my tungsten. I noticed because it changed colors. It went from a nice arc to a blue-green. Alright, grinded it, so should be good here now. It's actually not too difficult, but definitely, I would say it's easier than aluminum, but alright guys, I'm going to show you what my TIG looks like with stainless onto aluminized steel. It doesn't look bad. Now, it could look better, but it doesn't look bad. There's a few spots I tried to fill because there were holes. But, I mean, what can I say? That doesn't look horrible. That looks pretty good. There's some dimes. Some. So yeah, huge learning curve. I'm assuming that the aluminized steel makes it harder, and I'm using stainless steel to weld it. I don't know if maybe I should use carbon steel. I'm not sure, but definitely gonna need more practice if I want shit to look like this. Although that's thin, and I would want wider welds there so they don't crack, but you know, whatever, heat input, stuff like that. So if you got pointers, you know, leave them in the comments below. Let me know what you think. Obviously, I know I'm a rookie, so I am open to some pointers and people telling me what I did wrong. So if you know what I did wrong, let me know in the comments, along with the aluminum stuff too. So, but for real, that's all for this one, guys. I'll check you on the next one. Deuces.